I'm using scikit-learn's QuantileRegressor to create a model that predicts a target variable, y, based on a predictor variable, x. I set the QuantileRegressor parameter to 0.5, and now I want to understand what that means for the model's predictions. The question asks which statements accurately describe the model's predictions. This line describes the specific type of model I'm using. A QuantileRegressor with a quantile of 0.5. This is important because the quantile parameter determines what the model predicts. A value of 0.5 means the model aims to predict the median of the target variable. Think of it like this. I'm trying to find the middle value of my target variable for each value of my predictor variable. This is simply the input variable. I use this variable to predict the target variable. It's the data I'm using to make the prediction. For example, it could be things like house size, age, and location if I'm trying to predict house prices. This is what I'm trying to predict. It's the output of the model. For example, if I'm predicting house prices, the house price itself is the target variable. I'm looking to predict this variable based on the predictor variables that I have. This statement says that the model predicts the median value of the target variable for each value of the input variable. Since I set Quantile to 0.5, and the 0.5 quantile is the median, this statement is correct. This statement is wrong because a QuantileRegressor with Quantile equals 0.5 predicts the median, not the mean. The mean is the average, while the median is the middle value when all the values are lined up. They are different things. This is true because the median is less sensitive to extreme values, outliers, than the mean. Outliers have less of an effect on the median. This statement is false. A standard linear regression model is more sensitive to outliers than the median-based QuantileRegressor. This is because linear regression calculates the mean, which is very sensitive to outliers. I'm setting up a prediction model using Sklearn's QuantileRegressor. I have one input variable, x, and one output variable, y, and I've set the Quantile parameter to 0.5. Now, let's figure out what that means for the model's predictions. That's incorrect. The Quantileregressor doesn't predict the average, mean. It predicts a specific point in the data's distribution, like a percentile. A regular linear regression model would predict the mean. This is correct. Because I am using the median, the middle value, extreme values, outliers, don't heavily sway my predictions like they would if I used the average, mean. No way. That's wrong. The Quantileregressor, especially when using the median, 0.5 quantile, is much less affected by outliers than a standard linear regression model, which relies on the mean and is therefore sensitive to outliers. Absolutely correct. With Quantile set to 0.5, the model is predicting the median, the middle value, of the target variable, y, for each possible value of the input variable, x. This is the main question. Let's break it down step by step. This is the overall topic. We are working with a model that finds the median. Hey Vamsi, when you set the quantile parameter in Sklearn's QuantileRegressor to 0.5, you're telling the model to predict the median. Think of it like finding the middle value in a sorted list of your target variable's values for each predictor value. This is the core question, Vamsi. We're using a QuantileRegressor from the Sklearn library. It's a machine learning model that tries to predict the relationship between an input, x, and an output, y. Importantly, we're setting the quantile to 0.5, so we want to find out what happens when we're specifically looking for the median. Here's a key advantage of using the median. Because the median is less sensitive to extreme values, or outliers, than the mean, average, our model is better equipped to handle those noisy data points. A few extreme values won't drastically change the model's predictions like they would with a model based on the average. This statement is true. Since I set quantile to 0.5, the model will predict the median, which is the middle value, of the target variable, y, for each unique input value, x. This is false. The QuantileRegressor predicts the median, not the average or mean. A linear regression would predict the mean. Incorrect. Linear regression models are very sensitive to outliers since they're based on the mean, average. The QuantileRegressor with quantile equals 0.5 is way less affected by those outliers. This sets the stage for the entire problem. We're dealing with a specific machine learning model, a QuantileRegressor and its behavior when looking for the median, quantile equals 0.5. I see that you are focusing on the quantile parameter in scikit-learn's QuantileRegressor . Setting quantile equals 0.5 specifically tells the model to predict the median value, which is the middle value when data is ordered. Think of it like finding the middle point in a line of students. This median prediction is less influenced by extreme values than the average or mean. That's a key point to remember. This statement is true. Because we set quantile equals 0.5 the model predicts the median, the central value of the target variable. For example, if you have 10 houses with prices ranging from $100,000 to $1 million, the model will predict the price that is right in the middle, and will not be affected if one house costs $10 million. This is also true. The median is less sensitive to outliers than the mean. Outliers are extreme values that don't represent the typical data. Using the median makes your model more resilient to these unusual values. It's like choosing the middle student's height. One very tall or short student won't drastically change the central height. This statement is false. The QuantileRegressor with quantile equals 0.5 predicts the median, not the mean, average. The mean is heavily affected by outliers. This statement is false. The QuantileRegressor using the median is far less sensitive to outliers than ordinary least squares regression that uses the mean. Think of it this way. A single extremely tall person in a classroom dramatically changes the average height, but it affects the median height much less. I'm looking at how scikit-learn's QuantileRegressor predicts values. Specifically, I'm focusing on understanding its predictions. This is a multiple-choice question testing my understanding of the QuantileRegressor. This question describes using a QuantileRegressor with to predict y from x. I need to determine which statements about the predictions are correct. This statement says that the QuantileRegressor predictions are the medians of y for each value of x. This statement says that the QuantileRegressor predicts the means of y for each x. This statement says the model handles outliers in the target variable well. This statement says the QuantileRegressor is as sensitive to outliers as a linear regression model. The Quantile parameter being 0.5 means the model targets the median. The median is the middle value when data is sorted. I'm trying to understand what the model's predictions actually represent. I see, we're using scikit-learn's Quantileregressor to predict y from x. The key here is that means we're aiming for the median prediction, not the average. This question tests your understanding of what that means for the predictions and how this model handles outliers. This statement is correct, because we set the model's predictions will represent the median value of y for each value of x. Think of it like this. For every input x, the model will give you the middle value of all the corresponding y values. This is incorrect. We're not calculating averages here. Quantileregressor focuses on finding medians, not means. Using the mean would be like using a standard linear regression model. This is absolutely correct. Because the model predicts the median, it's much less sensitive to outliers than a model that predicts the mean, like ordinary least squares regression. Outliers have less of an effect on the median. This statement is incorrect. A major advantage of using the median is its robustness to extreme values. A standard linear regression model, which aims for the mean, is heavily influenced by outliers. QuantileRegressor is way more resilient. The QuantileRegressor, especially when, is designed to be robust to outliers. This is a significant benefit over methods that rely on the mean. Because the median is less affected by extreme values, the output of the QuantileRegressor with is the median prediction. This simply means that for a given input, the model outputs the middle value of the target variable's distribution. I'm presenting a multiple-choice question about Sklearn's QuantileRegressor, a machine learning model used for regression tasks. We'll explore how it handles data and makes predictions. Here's the core question. We're using a specific type of regression model called QuantileRegressor from the popular Python library Sklearn. We'll see which statements accurately describe what this model does. The focus is on the predictions when we set the quantile parameter to 0.5. This option suggests the model's output is the median of the target variable. We'll examine if this is correct in the context of "quantile equals 0.5". This option proposes that the model outputs the average of the target variable. This contrasts with the previous option, and we'll check if this aligns with how QuantileRegressor works. We need to see if this regression model is resistant to unusual data points. We'll explore if outliers significantly affect the model's predictions. This option proposes that the model reacts to outliers similarly to standard linear regression. We will investigate if this holds true. This shows what the model ultimately provides: predictions based on the input data and the chosen quantile. This is the result of the model's analysis. This highlights a key characteristic: the model's predictions are robust to outliers. We will explore how this robustness is achieved and if it is a defining feature of this type of regression. This is introducing the structure of the QuantileRegressor model, showing a simplified view of its internal workings. This is an important concept. This specifies the type of data this model works with. It takes both predictor variables, x, and target variables, y, as input. We need this to make accurate predictions. This clarifies a key parameter setting in this problem. The quantile parameter being set to 0.5 means the model is predicting the median.